Looking at the map right now, what we're seeing across the United States is a weather pattern that's divided into two main regimes. In the north and across the mountainous west, we have cold air and snow zones. In the southeast and extending through the Appalachian region into the Ohio Valley, we have a large precipitation shield, with some areas showing thunderstorm activity. This isn't a single unified storm system. Instead, we have multiple separate active zones operating at the same time, and each one is producing different types of weather in different parts of the country. Let me walk you through what's happening, starting with the most dominant feature on the map. The biggest story right now is the large precipitation shield that's positioned across the southeastern United States and extending up through the Ohio Valley. This system stretches from Arkansas through Tennessee, Kentucky, West Virginia, and into Ohio. This is a massive area of organized precipitation, and it's the main weather maker across the eastern United States right now. If we look at which states are being most affected, Arkansas, Tennessee, Kentucky, West Virginia, and southern and eastern Ohio are right in the heart of this system. On the edges, we're also seeing impacts in northern Alabama, northern Georgia, and western Virginia. The colors on the radar map show us intensity, and the greens and yellows across Kentucky and Tennessee indicate heavier rainfall cause. These are areas where rain rates are elevated, and that means accumulation is going to add up quickly. But here's what makes this system particularly interesting. We're seeing lightning strikes showing up on the map. Those lightning indicators tell us that this isn't just stratiform rain. There are convective elements embedded within this system. That means thunderstorms. When you have thunderstorms mixed into a larger precipitation shield, you get pockets of much more intense rainfall. These thunderstorm cores can produce brief periods of very heavy rain, and in some cases, they can even produce strong wind gusts. So if you're in Tennessee, Kentucky, or Arkansas right now, and you see a thunderstorm move through, don't be surprised if rain rates suddenly increase and conditions deteriorate quickly. Now, on the northern edge of this precipitation shield, particularly along the Ohio and West Virginia border, we're seeing a transition. The map shows a more scattered, spotty precipitation pattern in this zone, and that's telling us something important. This is where the rain-snow line is setting up. In this transition zone, precipitation type can change. You could see rain, then sleet, then snow, all within a short period. The exact position of this line depends on temperature, and small shifts in the temperature profile can move this line north or south by 50 or 100 miles. So if you're in southern Ohio, northern West Virginia, or even parts of Indiana, pay close attention to what's falling from the sky. It might not be the same all day. Let's talk about the risks associated with this large southeastern precipitation shield. First, there's flooding potential. When you have persistent rainfall over the same area for hours or even days, water accumulates. Streams and rivers rise. Low-lying areas can flood. And in mountainous terrain like the Appalachians, that water runs off quickly, which can lead to flash flooding in valleys and near small streams. If you're in eastern Tennessee, eastern Kentucky, or West Virginia, be especially aware of this risk. Don't drive through standing water. Don't camp near streams. And if you're told to evacuate, do it. Second, those thunderstorm pockets we talked about can produce localized, intense rainfall. Even if the broader system isn't causing widespread flooding, a thunderstorm that sits over one spot for 30 or 40 minutes can dump enough rain to cause localized flash flooding. This is especially true in urban areas where drainage systems can be overwhelmed. Third, the transition zone where rain meets snow is always tricky. Freezing rain and sleet can make roads extremely hazardous. Even a light glaze of ice can turn a highway into a skating rink. If you're near that transition line, monitor conditions closely and be ready for travel to become dangerous. Now let's shift west and talk about the Rockies and the Intermountain West, because there's a completely different weather story happening there. Across Idaho, Utah, Nevada, Wyoming, and parts of Colorado, we're seeing scattered precipitation areas that are more cellular or banded rather than one large shield. And the key here is that we're seeing snowflake indicators mixed in with the precipitation. That tells us snow is falling, especially at higher elevations. The mechanism here is orographic lift. Moist air moves inland from the Pacific, encounters the mountain ranges, and is forced upward. As it rises, it cools, and moisture condenses and falls as snow in the higher terrain. So if you're in Boise, Salt Lake City, or Elko, you're likely seeing a mix of rain in the valleys and snow in the mountains. But as you go higher in elevation, it's all snow. This creates hazardous conditions on mountain passes. Roads like I-80 through Wyoming or I-70 through the Colorado Rockies can become treacherous. Visibility drops, snow accumulates, and even with plowing, conditions can deteriorate quickly. If you're planning to travel through mountain passes in the Rockies, check road conditions first. Have chains or four-wheel drive ready, and give yourself extra time. The precipitation in this region isn't a uniform blanket, it's more localized. You have cells and bands of heavier precipitation surrounded by lighter or even dry areas. That means conditions can vary significantly over short distances. One mountain pass might be clear, while another just 50 miles away is buried in snow. That's the nature of mountain weather. It's highly dependent on local topography and wind patterns. Now let's talk about the northern snow band, because there's a third active zone across the northern United States and southern Canada. If we look at the map, we can see snowflake indicators stretching along the northern tier, particularly north of the Great Lakes. This is a cold regime zone. Temperatures are below freezing, and any precipitation that falls is going to be snow. This zone extends from the northern plains through the upper Midwest and into southern Canada. The Great Lakes region deserves special attention here. When cold air moves over the relatively warmer waters of the lakes, it picks up moisture and dumps it as snow on the downwind side. This is lake effect snow, and while the video doesn't show massive lake effect activity right now, the structure is there. The cold air is in place, the lakes are relatively warm, and that means lake effect bands could set up, especially on the eastern and southern shores of the lakes. If you're in western Michigan, northern Indiana, or western New York, be aware that localized heavy snow is possible, even if the broader pattern doesn't look that active. Temperature is the key to understanding all of this, so let's talk about the temperature map. What we're seeing is a very clear north-south gradient. Across Canada, the northern United States, and the Rockies, we're seeing blue and purple tones. That's cold air. Temperatures are at or below freezing. In the southern United States, including Texas, the Gulf Coast, the Deep South, and Florida, we're seeing green and yellow tones. That's warmer air. Temperatures are well above freezing. This gradient is what's controlling precipitation type. In the southeastern precipitation shield, most of what's falling is rain because temperatures are above freezing. But on the northern edge of that shield, along the Ohio and West Virginia border, we're right at the freezing line. That's where the transition happens. North of that line, it's cold enough for snow. South of that line, it's too warm. And right along the line, you get a mix. The exact position of this line can shift based on small changes in the weather pattern. And that's why forecasting precipitation type in that zone is so challenging. In the Rockies, elevation plays a huge role. Even though the broader temperature pattern might show above freezing temperatures at lower elevations, go up 3,000 or 4,000 feet and it's a completely different story. That's why you can have rain in Salt Lake City and heavy snow in the mountains just east of the city. Elevation creates its own temperature gradient, and that's critical for understanding mountain weather. Now let's talk about Canada briefly, because Canada is part of this story. Across southern Canada, particularly in the prairie provinces and north of the Great Lakes, we're seeing snow bands. This is the source region for the cold air that's affecting the northern United States. Canada is essentially feeding cold air southward, and that cold air is what's setting up the snow regime across the northern tier of the US. Without that Canadian cold air supply, the northern snow zone wouldn't exist. So when we talk about cold air intrusions into the United States, we're really talking about air that originated over Canada and then pushed south. There's also some activity in the Atlantic that's worth mentioning. Off the coast, particularly near the Bahamas and over the ocean, there's a separate area of convective precipitation. This isn't directly impacting the United States right now, but it's a sign that there's energy in the atmosphere over the Atlantic. If this activity were to organize and move westward, it could become a factor for the East Coast. But for now, it's staying offshore, and the main story for the US is the large precipitation shield over the southeast and the mountain snow in the west. Let's talk about what this means for specific regions and what the impacts are. If you're in Tennessee, Kentucky, Arkansas, or West Virginia, you're dealing with persistent rain and embedded thunderstorms. Roads are going to be wet, visibility could be reduced during heavier downpours, and there's a flood risk, especially in areas with poor drainage or near streams and rivers. If you're driving, slow down, use your headlights, and don't attempt to cross flooded roads. If you're in southern Ohio, northern West Virginia, or parts of Indiana, you're in the transition zone. Watch what type of precipitation is falling. If you start to see sleet or freezing rain, conditions can deteriorate rapidly. Roads can ice over in minutes. If that happens, the safest thing to do is delay travel if possible. If you're in the Rockies or the Intermountain West, mountain travel is the main concern. Check past conditions before you go. Carry emergency supplies in your vehicle, and be prepared for conditions to change quickly. What's dry in the morning could be snowing heavily by afternoon. If you're in the northern plains or around the Great Lakes, you're in cold air. Any precipitation that develops is going to be snow, and if lake effect bands set up, snow totals can climb quickly in localized areas. Keep an eye on radar if you're in a typical lake effect zone. And if you're in the south, in places like Georgia, Alabama, or the Carolinas, you're on the southern edge of this system. You might see some rain, especially in northern areas, but the main impact are further north. That said, if any of those thunderstorm cores drift south, you could see brief, heavy rain and gusty winds. The bottom line is this. The United States is dealing with a divided weather pattern right now. We have a large, organized precipitation shield across the Southeast and Ohio Valley, bringing rain and embedded thunderstorms. We have mountain snow across the Rockies and Intermountain West. We have a northern snow band supported by cold Canadian air. And we have a transition zone where rain meets snow and conditions can change quickly. Each region is experiencing its own weather story, and understanding which zone you're in is key to knowing what to expect. This pattern is going to persist for the next day or two, so if you're in an affected area, stay informed, monitor conditions, and be prepared for the specific hazards in your region.